As the digital age continues to revolutionize the way in which we live and interact with the world, one field stands at the forefront of it all: artificial intelligence. From advanced algorithms embedded in machine learning processes to the mystery box of neural networks in deep learning, AI is changing the way in which we work, communicate, and even think. But as we continue to embrace the potential of this technology, we must also consider the ethical questions it raises. Will AI bring about a utopia, or will it lead to unforeseen consequences? Will it bring us closer together, or will it drive us further apart? Join us as we delve into the complex world of artificial intelligence and discover the endless possibilities in a multi-video Trinizone series. First, let's go back to the beginning. What is AI? And when was it created? AI, or artificial intelligence, existed in various forms prior to obtaining the formal name of AI. Its roots go back even further than Alan Turing. However, we're going to be skipping past Alan Turing and speaking primarily about a particular project. The Dartmouth Summer Research Project on Artificial Intelligence was a summer workshop considered to be the founding moment of artificial intelligence as a field of research. It's interesting. The first paragraph of words used to give birth to AI sound almost prophetic. We propose that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of the conjecture that every aspect of human learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. An attempt will be made to and how to make machine use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. We think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. The article outlines a proposal for a research project on artificial intelligence to be conducted at Dartmouth College in the summer of 1956. The goal of the project was to explore the feasibility of creating intelligent machines that can perform tasks that currently require human intelligence, such as learning, problem solving, and decision making. The project proposed to use a variety of methods to achieve this goal, including symbolic reasoning, pattern recognition, and self-improvement. Symbolic reasoning involves representing knowledge in a symbolic form that can be manipulated by a machine, while pattern recognition involves using machine learning algorithms to identify patterns in data. Self-improvement, also known as machine learning, involves using data to improve the performance of a machine over time. The project was funded by a grant from the Rockefeller Foundation and was led by a group of researchers who are now widely considered to be the pioneers of the field of artificial intelligence, and their work laid the foundation for many of the advances in AI that we see today. In fact, if you observe the paper in detail, you can see the foundations of machine learning combined with neural networks being furthered by ML McKinstry. It is not difficult to design a machine which exhibits the following type of learning. The machine is provided with input and output channels and an internal means of providing varied output responses to inputs in such a way that the machine may be trained by a trial and error process to acquire one of a range of input-output functions. We also see more additions to the foundations of natural language processing by John McCarthy. These things contributed to the progress of things like ChatGPT. He says, "I propose to study the relation of language to intelligence. No attempt has been made to make proofs in the artificial languages as short as informal proofs. It therefore seems to be desirable to attempt to construct an artificial language which a computer can be programmed to use on problems requiring conjecture and self-reference. While John McCarthy did state his issues with attendance and participation of certain members within the project, there was progress made for the industry of AI. The term artificial intelligence itself was coined by John McCarthy during the conference. Another one of the conference's attendees, Arthur Samuel, would go on to coin the term machine learning in 1959 and create the Samuel Checkers playing program on one of the world's first successful self-learning programs. What is machine learning? Machine learning is a subfield of artificial intelligence that allows for software applications to learn and improve their performance without being explicitly programmed. It involves training algorithms on large datasets to recognize patterns and make decisions. One of the key requirements for machine learning is structured data. Structured data is data that is organized in a well-defined format, such as a table or a spreadsheet, and can be easily processed by machine learning algorithms. Structured data allows machine learning algorithms to easily identify and extract features and patterns from the data, which is important for training and evaluating the performance of any particular model. On the other hand, unstructured data, such as texts or images, can be more challenging for machine learning algorithms to process. Unstructured data may require additional pre-processing and feature extraction steps to convert it into a format that can be used for machine learning. And that is where deep learning comes into play. You see, deep learning is a type of machine learning that involves training artificial neural networks on large datasets to recognize patterns and make decisions. Neural networks are a type of machine learning model that is inspired by the structure and function of the human brain. They are composed of layers of interconnected neurons, which are mathematical functions that process input data and passes it to the next layer, such as image and speech recognition, natural language processing, and decision making. They are particularly useful for tasks that involve large and complex data sets rather than being explicitly programmed. And the learningception begins. One of the key features of deep learning is its ability to support machine learning by deciphering unstructured data, again, such as text and images. Some developers combine both methods to create even more complex solutions. Some even pit neural networks against each other, creating GANs, or generative adversarial networks, which is leading for a lot of the new age AI hype that we see in the mainstream today. The ability for deep learning algorithms to effectively process and analyze unstructured data makes them a valuable tool to support AI systems and serve a particular role. So, why do we care to use these technologies? Well, the reasons are actually endless. There are many benefits to using AI technologies. For example, in healthcare, artificial intelligence is being used to improve the accuracy and efficiency of medical diagnoses. For example, deep learning algorithms can be trained to analyze medical images such as X-rays, CT scans, and MRI scans to detect patterns that indicate the presence of diseases such as cancer and more. We can also highlight how artificial intelligence is being used to make transportation safer and more efficient, as well as making self-driving cars a reality. In fact, we see experts already speaking on how AI can revolutionize the global supply chain, from back office automation, logistics automation, warehouse automation, and more. AI has already begun to seep into the global supply chain. While AI is not perfect by any stretch of the imagination in its current form, it is in fact only growing stronger and stronger. It is clear to see that AI technologies are here to stay. Thus, it should also be clear to see whoever can bring value to the AI space will reap massive rewards in the long run. This means we need to know the areas in which AI struggled today in order to know how to position ourselves in the market for the future. So, what are the current weaknesses of AI and how can we make it better? Well, my friends, this is where we start talking about knowledge graphs and/or the OriginTrail decentralized knowledge graph.
Oksana, what's my first appointment today?
You have a drop-in visit with Dr. McCormick, but road conditions show a 40-minute delay.
Have marketing send an email, I'll follow up after. Who's next?
You have a meeting with Dr. Patel. I suggest also visiting Dr. Lewis in the same practice. He attended a thyrophene webinar last week and ordered a biopsy yesterday.
Accept. Add Dr. Lewis to my calendar.
She want a man that truly understand. I tell her that I want a girl that buy her OriginTrail. She tell me she go find a man that living in Japan. I tell her I go come up there and buy up all the land. Now she love the DKD, she truly understand. Why her brother man going so crazy with the plans? She couldn't give it to me if I die, and that is why I love ya so. And that is why I love ya so. She couldn't give it to me if I died. That is why I love ya so. And that is why I love ya so.
Before we dive into the knowledge graph, there's one particular piece of text I want to highlight from this research paper. It says, the speeds and memory capacities of present computers may be insufficient to simulate many of the higher functions of the human brain, but the major obstacle is not the lack of machine capacity, but our inability to write programs taking full advantage of what we have. Now, this quote, initially from the research paper, resonated deeply with me, primarily because this is something Dr. Bob Metcalf frequently discussed as the neuron transistor paradox.
All the gigabit internet is arriving. One could argue, and some do, that we're done now. The internet's done. We're going to hit a gigabit, and who could use more than a gigabit? I mean, that's crazy. So the internet is done. And I'd like to argue that the internet is not done. It's not even begun to be done. Another way of putting it is we don't yet know much about connectivity. We're just beginning to learn about connectivity. And my favorite proof of this position is the neuron transistor paradox, I call it. You know, our brains are all made of these neurons. What is it, 10 to the 11th of them, interconnected with these little wires. And the neuron is, compared to a transistor, a neuron is a huge thing. I mean, you can even see it. Whereas, you know, transistors are down at 5 nanometers. neurons are still things you can see. They're big, big things. And they're slow. They go at, in milliseconds on a good day, whereas transistors are going, gigahertz at the speed of light. So you have these pitiful neurons that have been hanging around for 5 billion years, and you have these transistors invented in 1947. And here's the paradox. Neurons make human brains, which are really, really smart, and transistors don't. So despite all their advantages in size and power consumption and speed, neurons still outcompute transistors. And why is that? And the answer is connectivity. And so there's a lot of progress ahead. We're all going to be making it in learning about connectivity and beginning there's plenty of headroom. That is, we have an existence proof for something that's better connected than anything we can build. It's called the neuron. And so there's plenty of headroom for connectivity. Connectivity is a thing, and OriginTrail is wise to pay attention to connectivity and enhance connectivity because it's a very powerful and fruitful direction to go. Do you have any comments based on those? Any questions?
We see that connectivity, or the power of connectivity, is a very important feature that, if anyone were to leverage, would lead to insane positive results. Some organizations are using machine learning to better leverage their data and deliver analytical insights. However, a variety of challenges exist, from gaining access to the right data to identifying outputs that are actually useful. The flexibility of the graph model, along with its explicit storage of data relationships, makes it not only easy to manage data coming from diverse sources, but also to search and explore that data to reveal new insights that would otherwise be very difficult to discover. As a sign of its growing popularity, in December 2020 at NeuroIPS 2020, one of the world's largest AI conferences, more than 136 papers had the word graph in their titles. In fact, an entirely new type of neural networks called graph neural networks have been combined with graph technology in biochemistry, drug design, and structural biology to achieve even greater results. This article by Neo4j, released in 2020, has this to say about the value of combining knowledge graphs with AI technology. They say, companies are increasingly using AI applications for decision making. However, due to the lack of contextual information, AI systems have not yet been able to achieve their full potential as reliable solutions for complex problems. Enter knowledge graphs, a logical way to capture data relationships and convey their meaning. Knowledge graphs drive intelligence into the data itself and give AI the context it needs for explainable, accurate, and repeatable results. Neither an AI or knowledge graph is new technology, but only lately have they come of age and joined forces. Data and compute power have contributed to their rise in the last decade. It's the powerful combination of the two that is spurring an explosion of interest in contextual AI. Rather than listen to the Trini Zone on Twitter repeatedly try to drive home that knowledge is our most valuable asset outside of love, for years, even Neo4j says, knowledge is every company's most prized asset. However, its value is limited unless organizations can leverage the knowledge in the correct context. This is where knowledge graph comes into play. Knowledge graphs explicitly surface the rich relationships between data that experienced domain experts naturally consider. After all, in reality, there are no isolated pieces of data, but only rich, connected domains all around us. A knowledge graph places data in context by establishing connections among data. A knowledge graph enriches the data's meaning and utility by adding a layer of semantics, thereby allowing software agents to reason about it. By adding relationships to data and enhancing it with semantics, knowledge graphs drive intelligence into data, making it smarter. Great. So knowledge graphs make AI way smarter. But there is actually even more value to extract from the combination of the two technologies. More specifically, machine learning depends on data. The more data and the higher the data quality and the more data variety, the better the results. Unfortunately, most data science approaches leave out contextual information because connections and data structures are difficult to process. However, knowledge graphs capture, persist, and make this contextual information usable, which means they enhance every step of the machine learning process. From data sourcing and training machine learning models to analyze predictions and applying results, contextualized AI systems are more reliable, robust, explainable, and trustworthy. So yes, not only do knowledge graphs make AIs contextually smarter, it makes debugging or finding issues within these complex systems significantly easier. This makes development much more streamlined and efficient. Due to the sake of time, I won't be able to dive into all of this, so you'll just have to take this as face value, but this is a fact. It's clear to see the value brought to AI by knowledge graphs. Thus, when you think about what knowledge graphs do for AI, then you think about OriginTrail, which is a decentralized network that combined the power of knowledge graph technologies with blockchain. Assets and their corresponding data in the knowledge graph are cryptographically anchored in blockchain. This creates the perfect foundation for builders of AI to construct human-centric data pipelines, hopefully creating a symbiotic relationship between data-hungry technologies and expended human capital. Fundamentally, the ability to leverage the power of connectivity, as stated by Bob Metcalfe, between various domains of knowledge over a decentralized network of verifiable data would be of great benefit to the artificial intelligence community.
I'm not going to say too much anymore about the V8. I'm going to leave it up to Branimir.
One of the most, personally for me, most exciting updates is, apart from all of these great things in Turing and Metcalfe, is the Berners-Lee phase, where we move towards basically once we enabled all of this infrastructure in Turing phase, parachain and DKG V6, and we start growing the graph and we get into the domain of network effects on the three layers that Giga mentioned, blockchain network effects, the network effects between enterprise systems, as Yuri has showcased them well, and then the network effects with additional data systems, such as decentralized data systems. Then we really get to touch a really, really big graph. And that is perfect segue into what I'm the most excited about, is actually moving towards where knowledge graphs meet AI. And that is one of the best substrates for this new industry, having very highly organized knowledge assets, verifiable information that is able to feed into the future of computer algorithms, which more and more, as you I'm sure all have seen, especially lately, are very much involving AI components. Things like ChatGPT and all other systems like the ones generating amazing imagery. Well, they're just the start. And one of the biggest problems of this space is, not having enough data, not having enough well-organized data to feed AI models, not having verifiability of this information, and finally, obviously, trust into this. Those are just some of the problems, but the DKG is very capable of tackling them and solving them towards these higher values and goals of really having a more sustainable future.
As knowledge graphs are perfectly suited to bring the pinnacle of context and the highest level of data lineage features to AI, effectively serving as the best foundation for almost any and all AI-based systems. OriginTrail is a technology stack unlike anything the world has seen before. As this decentralized networks continues to scale, we will continue to take notice of all the growing use cases of the DKG. So folks, do not forget to do the most important thing in this video. Like, share, and subscribe. We'll see you next time.